Hello everyone. In this video we will be going over kinematics of a particle, force and acceleration. So to get started we have Newton's second law, which basically states that the force exerted on the particle is equal to the mass times the acceleration, and the acceleration is in the same direction as that force. So moving on, and also the sum of the forces on the particle equals the mass times acceleration. Now this can be broken down into the coordinate x, y, z, so we have sum of fx equals max and so on. So let's do a small example to kind of go over this. So we have this box, 50 kilograms. We know it's moving in this direction in the horizontal x. We have this force P on it with 400 newtons at an angle 30 degrees, and we know that the friction coefficient is 0.3. So the first thing to do is we draw the free body diagram. So we have the weight, which is equal to mass times gravity. We have the P, we have the reaction here, and we have the friction force, which is actually equals the friction equals mu K times the reaction. So first thing to do, we break them down. We do the x first. So we have 400 cosine 30 minus 0.3 and c equals 50 times the acceleration and the x, which is actually equals to the acceleration because this body is not moving upwards. And if we do the y, we have nc minus mg, that's the weight. And oh, this should not be that. This is my mistake. This is equal to 0. So from this we can get NC. We get 290.5. Oh no, sorry. Yeah, so that's actually the answer, but it's gonna be minus plus 400 sine 30. And then we get the acceleration to be 5.185. Now let's keep going. Let's do the normal and tangential coordinates. So we have this as the path, the origin here. The normal direction always goes towards the origin. We have tangential, and we have B, which is vertical. This is going to be vertical. So same as before, we break them down. Here notice sum of FB equals 0 because it does not move upwards. Next we're going to do cylindrical coordinate. So we have R, theta, and Z that I have here shown. So R is from the origin to the particle. Theta is in the theta direction, which is actually perpendicular to R. And that's the tangent. And actually Z is upwards. So we have here an angle which is from R to the tangent. Now to get that angle, we have tangent equals R over the R d theta. Now this basically concludes this chapter. Thank you everyone for listening.